Unit 4.7, L'Hopital's rule. If you recall, when evaluating limits, first try direct substitution. So in this equation, we used direct substitution and found that a equaled 1/3. And in this equation, you can't use direct substitution because it'll end up being 0 over 0, and you know we can't have 0 over 0. So we factor out, and then we find that you can cancel x minus 2. And then the equation is just x minus 5. You plug in 2 for x, and then it becomes 2 minus 5, and that's just -3. L'Hopital's rule. Suppose f of a equals 0 and g of a equals 0, and the limit of as x approaches a of f of x over g of x equals 0 over 0 or infinity over infinity. L'Hopital's rule allows you to apply the following. The limit as x approaches a of f prime of x over g prime of x. Evaluate each limit, use L'Hopital's when possible. So first, we sort of direct substitution the numerator and the denominator separately. So the limit as x approaches 2 of x minus 2 equals 0, and the limit as x approaches 2 of 3x cubed minus 6x squared plus x minus 2 also equals 0. You can find the derivative of the numerator and denominator. So this becomes the limit as x approaches 2 of 1 over 9x squared minus 12x plus 1. And now you could try direct substitution. You plug in 2 and you'll find that the limit is 1 over 13. Over here, same situation. Limit as x approaches 0 of sine of 6 of x equals 0. And the limit as x approaches 0 of x also equals 0. So you find the derivative, which is 6 cosine of 6x over 1. And plug in your zeros, and you'll find that this equals 6. Right here, the limit as x approaches 0 of 1 minus cosine of x equals 0, and the limit as x approaches 0 of x squared also equals 0. So we can find our derivative. So the limit as x approaches 0 of sine of x over 2x, we plug in our zeros. We find that this also equals 0 over 0. So we have to find the derivative again. Oh, first we have to check. So limit as x approaches 0 of sine of x, it does equal 0. The limit as x approaches 0 of 2 of x also equals 0. Now you can find the derivative of this. So it becomes the limit as x approaches 0 of cosine of x again, and over 2. Now we plug in our zeros. We find that the limit is 1/2. Number 5. We check them separately. So the limit as x approaches infinity of 2x squared equals infinity, and the limit as x approaches infinity of e to the power of 2x equals infinity. So now we find the derivative. So this becomes x as limit of x approaches infinity of 4x over 2 to e to the power of 2x. Plug it in again. So the limit as x approaches infinity of 4x equals infinity, and the limit as x approaches infinity of 2e 2x also equals infinity. So now we know that this also doesn't work, so we have to find the derivative again. And you find that this is limit as x approaches 4 over 4e to the power of 2x. Now if we plug in infinity, this will become 4 over infinity, which is 0, and now we finally have our answer.